In this video, we're going to discuss how to find slant asymptotes for rational functions. So some books call it a slant asymptote and some books call it an oblique asymptote. But a slanted line or oblique line is just a line that's not horizontal or vertical. So we've discussed horizontal and vertical asymptotes previously. Now we're discussing a slanted or oblique line that serves as an asymptote. The only time a rational function is going to have a slant asymptote is if the degree of the numerator is exactly one higher than the degree of the denominator. And when we discussed horizontal asymptotes, we had three cases, right? One case is that the degrees are the same, one case is that the numerator has higher degree, and one case is that the denominator has higher degree. And we said that if the numerator has higher degree, there's no horizontal asymptote. So since that has to be the case for a slant asymptote, we will never have both a horizontal asymptote and a slant asymptote. It's going to be one or the other. You can have neither. We're not going to get into those in this class. If your degree of your numerator was too higher than the degree of the denominator, for example, then something else would happen. We're not going to get into that here. We're just going to look at cases where the degree of the numerator is exactly one more than the degree of the denominator. So here that's the case because the numerator has degree 3 and the denominator has degree 2. So since the numerator has exactly one higher degree than the denominator, we have a slant asymptote. Now to find the slant asymptote here, we're going to need to use long division. If you prefer synthetic division, you can use that when it works, but synthetic division requires your divisor to be linear. So here we need long division. And I'm going to put a placeholder here plus 0x squared in case I end up with any x squared terms and I need some place to subtract them from. And we'll proceed with our long division. So x squared times x gives us x cubed. We're going to take that x times the divisor. We get x cubed minus x. We're going to subtract that from the dividend. X cubed minus x cubed is 0. And then here for the x, I wrote this in the wrong place. It was just x to the first, so I need to write it here. And we have negative 2 minus negative 1 for the coefficients there. So negative 2 plus 1, which is negative 1. And we didn't end up needing that placeholder, so we have 0 minus 0 there essentially. And here we have, for the constant, 1 minus 0. So we still have a plus 1. Now anytime you're doing long division, you know you're done if what you have down here has less degree than your divisor, which is the case here. Right? We have degree 1 here, our divisor was degree 2. So that tells us we're done, and this is our remainder. And we actually don't care about the remainder when we are finding slant asymptotes. The slant asymptote is going to be the line y equals whatever the quotient is. So here that's the line y equals x since x was our quotient. We'll look at another example here. Now this one, the divisor is linear, so you can use synthetic division if you want. We know we have a slant asymptote because we have degree 2 in the numerator and we have degree 1 in the denominator since it's x to the first. And so the numerator has higher degree and the difference between them is exactly 1. So that's why we have a slant asymptote. I have a feeling this time I am going to need a placeholder here. I'm going to put a plus 0x. And then x times x would be x squared take the x times the divisor, we get x squared minus 5x. Subtract that, x squared minus x squared is 0. And then for the linear terms, we have 0 minus negative 5, which is 0 plus 5. And then 1 minus 0 for the constant. And we can keep going because the degree of what we have here is the same as the degree of our divisor. So we have one more round here. 5 times x would give us 5x. So we'll put a plus 5 here. And we'll take that 5 times the divisor. Subtract that off. 5x minus 5x is 0. And then we have 1 minus negative 25, which is 1 plus 25, so 26. And that has degree 0 because it's a constant, and so that has less degree than our divisor. So that's our remainder, 26. Again, we don't need that. The slant asymptote is going to be the line y equals x plus 5, since x plus 5 was our quotient.